Lesson: Overview of Cyber Threat Intelligence. Cyber threat intelligence is a critical component of modern cybersecurity strategies, providing actionable insights into potential threats that can compromise an organization's digital infrastructure. The integration of artificial intelligence into CTI processes significantly enhances the capability to predict, detect, and respond to cyber threats. This lesson delves into the theoretical foundations of CTI, the role of AI in augmenting these processes, and the practical implications for enhanced cybersecurity. CTI involves the collection and analysis of information about current and potential attacks that threaten an organization. It focuses on understanding the tactics, techniques, and procedures used by cyber adversaries. By identifying and mitigating these threats proactively, organizations can better protect their assets and information. CTI encompasses various types of intelligence, including strategic, tactical, operational, and technical intelligence. Each type serves a specific purpose, from informing high-level security policies to providing detailed technical data for system defenses. AI plays a pivotal role in enhancing CTI by automating data collection, analysis, and threat detection processes. Traditional CTI methods often struggle with the sheer volume of data and the speed at which cyber threats evolve. AI technologies such as machine learning, natural language processing, and anomaly detection offer advanced capabilities to address these challenges. Machine learning algorithms can analyze vast amounts of data to identify patterns and anomalies that might indicate a cyber threat. These algorithms improve over time, learning from new data to enhance their predictive accuracy. Natural language processing allows AI systems to analyze unstructured data, such as threat reports, social media posts, and dark web communications. By understanding and extracting relevant information from these sources, NLP enhances the ability of CTI systems to identify emerging threats and threat actors. For example, AI-powered systems can scan cybersecurity forums and dark web marketplaces for discussions about new vulnerabilities, malware, or attack methods. This proactive approach enables organizations to fortify their defenses before an attack occurs. Anomaly detection is another crucial AI capability for CTI. This involves identifying deviations from normal behavior within a network or system, which may indicate a potential threat. AI systems can learn the normal patterns of network traffic, user behavior, and system operations, flagging any anomalies that could signify malicious activity. For instance, if an AI system detects unusual login attempts or data transfers at odd hours, it can alert security teams to investigate further. By continuously monitoring and analyzing network activity, AI enhances the ability to detect and respond to threats in real time. The integration of AI and CTI also facilitates the automation of threat response actions. Once a threat is detected, AI systems can automatically execute predefined response protocols, such as isolating affected systems, blocking malicious IP addresses, or deploying patches. This rapid response capability is essential in minimizing the potential damage caused by cyber attacks. Automated responses can significantly reduce the time between threat detection and mitigation, which is crucial in preventing data breaches and other security incidents. AI-enhanced CTI systems also contribute to improved threat intelligence sharing among organizations. By leveraging AI, organizations can anonymize and share threat data without exposing sensitive information. This collaborative approach enhances the collective cybersecurity posture of participating entities. For example, AI can help identify common attack vectors and threat actors targeting multiple organizations, enabling a coordinated defense strategy. Despite the numerous advantages of AI and CTI, there are challenges and limitations to consider. One significant challenge is the quality and reliability of data used to train AI models. Poor quality or biased data can lead to inaccurate threat detection and false positives, undermining the effectiveness of CTI efforts. Ensuring that AI systems have access to diverse and high-quality datasets is essential for their success. Additionally, the dynamic nature of cyber threats requires continuous updates and retraining of AI models to maintain their effectiveness. Another challenge is the potential for adversarial attacks against AI systems. Cybercriminals can exploit vulnerabilities in AI algorithms to evade detection or manipulate the system's outputs. For example, attackers might use techniques such as adversarial machine learning to create inputs that deceive AI models into misclassifying malicious activities as benign. Addressing these vulnerabilities requires ongoing research and development to enhance the robustness and security of AI algorithms. Moreover, the integration of AI and CTI raises ethical and privacy concerns. The use of AI to monitor and analyze network activity and user behavior must be balanced with respect for individuals' privacy rights. Organizations must implement transparent policies and practices to ensure that AI-driven CTI efforts comply with legal and ethical standards. This includes obtaining proper consent for data collection and ensuring that AI systems are used responsibly and fairly. In conclusion, AI significantly enhances the capabilities of cyber threat intelligence by automating data collection, analysis, and threat detection processes. Through machine learning, natural language processing, and anomaly detection, AI systems provide advanced insights into potential cyber threats, enabling organizations to respond proactively and effectively. The integration of AI and CTI also facilitates improved threat intelligence sharing and automation of threat response actions. However, challenges such as data quality, adversarial attacks, and ethical considerations must be addressed to fully realize the potential of AI in enhancing cybersecurity. By leveraging AI, organizations can strengthen their defenses against the ever-evolving landscape of cyber threats, ensuring a more secure digital environment.